One of the things I noticed playing with the ZVS driver a while back, I lost the footage of it, but I had a driver I put together that was pretty much the same circuit. Using these FETs I pulled from a TV board. They were surface mount, and I butchered them, so I had to file them down and get them on heat sinks, but very low RDS, and this particular circuit needed a very specific capacitor value for it to work at all. But I had this coil going on it, and now I've got this coil. Well, what I noticed early on is I randomly grabbed a roll of bell wire one time, and it was like 18, 19 turns, and it was still on the plastic spool. So it was two wires, and I wired it up like a bifilar, and it was the center tap set up, so I used that. And for whatever reason, that thing was heating up thick, solid screwdrivers almost instantly. But it had a very small diameter. The wire was maybe a little thinner than this, talking like 18 gauge copper. And obviously the problem was not only was the coil former, the spool melting, but the wire was melting also. It had insulation on it. But here's sort of another representation of that, except this has just got the no center tab, just the one coil. But it's about the same gauge, and the whole point is this actually worked out better than the sticker coils, you know. So when you're using these, at least I had the impression I need to up the wire gauge because it's getting too hot, and I need to use thicker wire. But it actually works much better with this size wire. Just sort of show. I've got it on 16 volts right now, just randomly. So it pulls a couple amps idle, and then I'll just use this little screwdriver here. When I put that little guy in, it starts pulling closer to 7-8 amps. It's hard to see, but put that guy in there, and then it starts heating up. Doesn't take long. But usually what I'm looking for is I'm expecting there to be about an amp or two idle draw. But I'm looking to get the largest upshoot in amperage when I put something in there. And using, say, a coil like this works, but it only pulls it up a couple amps using the same style screwdriver, whereas obviously I've got a much smaller diameter, which is making a difference there. But it's the just the amount of turns I could fit using that wire size, and that wire size also seems to work a lot better. So I don't know, just something about the thinner copper wire seems to work out better. Put another load in there. Put this razor blade in there. So that really pulls it down. Put that in there, it starts to pull more than the supply can handle, which is 10 amps in that particular supply. So I would be able to get this red hot super quick if I could push more than 10 amps in it, but this won't do that. But no, it still heats it up pretty quick. Doesn't take long for it to get a razor blade red hot, and that razor blade is being cooled by this relatively large sink that it's on. I can hear just from the fan speed the voltage is dropping. We've got a relatively quiet fan on there, but yeah, so I see a lot of ZVS circuits out there. This one works pretty good from 12 volts, but you know, it more or less came down to using this smaller gauge wire. I could sit and play with all these other components all day long using bigger coils, thicker wire, but like I say, I had the best results with something about that size. Actually magnetizes whatever's in there pretty good. Old faithful again. just the tip. So something like that's not instant. Still takes a little bit of time, but it gets it up there, so it's already getting your bread. I don't want to totally destroy the temper on that, but yeah, you get the idea. Thin coil. Thanks to very low own resistance FETs, they don't really get warm. It's the one capacitor down there that I'm worrying about keeping cooled. That's pretty much it.